Hi everyone, it's Professor Walker Waugh, and today we're talking about significant figures. Now, again, I want to remind you, do not look at this YouTube video while driving. Make sure that your screen is black or you have some navigation app up. Otherwise, you can get a ticket like I almost did. Now, let's get into the meat of it all. So what is significant figures? Significant figures, it tells us about the precision of the number. Now, this is very, very important, particularly if you're trying to reproduce someone else's data. If they write it a certain way with a certain number of significant figures or significant digits, you have to follow those rules that I'm going to teach you about right now, because otherwise you can cause an explosion. So let's look at the next slide. There are only 5 basic rules. The first rule is digits 1, 2, 3, 4, 5, 6, 7, 8, and 9 will always be significant. That means you cannot omit it. You cannot just drop it because you feel like it. For instance, if I said 298.9 grams, okay, listen to me, 298.9 grams, how many significant figures would that be? And I call them sig figs because it's nice and short. That would be 4 sig figs because all of those digits are significant. Now, if you're reproducing some kind of experiment and the author said that you had to have that much precision to the tenths, and he said 298.9 grams, but your balance can only give it to you to the ones, and so you said, oh, I'll just round it to 299 grams. Guess what you could do? You could say boom, baby, boom, and blow up the whole lab, because 299 is not as precise as 298.9. You only have 3 significant figures in 299 grams. Do you understand what I mean? All right. So the first rule, digits 1 through 9 are always significant. Don't omit them. So what's the only digit we don't have? 0. Zeros can give you hell. So let's look at this very, very clearly, and let's go through the rules. Now, we know how to put numbers in scientific notation, so some of those things will apply here. Beginning zeros, this is rule number 2. Beginning zeros are not significant. What do I mean? 0.0000048. All of those beginning zeros are not significant. Only the 4 and the 8 are significant. So there's only 2 sig figs. So you can easily put that in scientific notation because we learned this already. So that would be 4.8 times 10 to the minus 5. Do you understand? So beginning zeros are not significant. So now let's talk about rule number 3. Trapped zeros. Trapped zeros means that you have zeros between 2 significant figures. So they are significant. I normally like to talk about money with this, but money has an infinite number of sig figs because it's an object. We'll talk about that later. But let's think of $202 versus $2,000,002. Which one would you want? The 2,000,002 if you're like me. So when you think of 202 grams with your measurements, there you only have 3 sig figs, the 2, the 0, and the 2. However, if you're talking about 2,000,002 grams, all of those zeros in between are significant. You cannot drop them. They are significant. So to put that into scientific notation, that would be 2.0000002 times 10 to the 6 grams. So you have 7 sig figs. Please remember that. And again, think about money. It just sort of makes it easy for you to recall. Now, rule number 4. This is the one rule where I jump up, I scream, I say, listen to me. Remember this rule. Every semester, at the end of the semester, somebody forgets and I just want to do evil things to them. Nonetheless, let's think about rule number 4. Zeros after a decimal point and at the same time after a significant digit are significant. What do I mean by that? 7.000. Okay, those ending zeros, that 7 point, then 000. So you've got 3 zeros after that decimal point, and at the same time it's behind the 7. So those zeros are significant. You cannot drop them. So that is 4 sig figs. Now, I don't care what comes first. It could be the decimal point or the sig fig or the sig fig or the decimal point. Either way. So another example, 0.700. So when you think about that, 0.700, that beginning zero is not significant. But those zeros behind the decimal point and also at the same time behind the significant figure, they are significant. So 0.700, that's 3 sig figs. And you cannot drop it. If you put in scientific notation, you would have to say 7.00 times 10 to the minus 1. You see the difference? I want you to think about this in your mind's eye so that you can understand it. Don't drop those zeros. If 2 things are taking place, there's a decimal point and there's a significant figure, then those zeros that follow are significant. Now, our final rule is a little bit different in your textbook, but I've got to give it to you the way we do it in general chemistry. The way the rule works is very, very simple. All you have to remember is that ending zeros, like 2000, those ending zeros will not be significant unless you put a decimal point at the end. And you're going to do this in general chemistry, so make sure that you do it correctly now. So 2000 without the decimal point is only 1 sig fig. So you would say 2 times 10 to the third in scientific notation. However, if you say 2000 dot, there's a decimal point at the end. You are telling me, scientist, that those zeros are significant. So I cannot drop them. So 2000 dot would be 2.000 times 10 to the third. Do you see the difference in the precision? Okay. Now we're going to do some examples just like it's going to appear on your quiz. So when you look at this, you should be able to do everything we've discussed thus far. We've got the scientific notation and the sig figs all incorporated in this one table. Let's look at this first example, and I'm going to write in green to make sure that you can see what the answers are. So when we look here and we remember how to put numbers in scientific notation, we have to bounce that ball back 3 times for 0.00390. Now, remember rule number 4. This 0 at the end is behind a significant figure and at the same time behind or after a decimal point. So you cannot drop it. So the answer would be 3.90 times 10 to the what? Minus, how many times we bounce that ball? 3. Do not drop that trailing 0. It's not trailing, it's significant. So how many sig figs do we have? 3 significant figures. Don't let me fool you. All right, now let's look at the next one. Here we go again. This 0 is significant. Why? In 698.0, this 0 is after the decimal point, after a sig fig, so it is also significant. You are not allowed to drop it. So let's put this in scientific notation, and we look at the original number. It's larger than 1, so we're going to bounce that ball back 2 times after the 6. So to put it in scientific notation, is 6.980. Don't let me fool you. Times 10 to the, how many times we bounced that ball? 2. So here we have a total of 4 significant figures. Now you better be able to work it either in decimal form or scientific notation to tell me how many sig figs you have. Don't say, oh, which way should I look? No, you look at both. It should be the same thing. All right, now let's look at the third one here. We have another 0. I think you see a theme going on here. This 0 is behind or after the decimal point, after the sig fig. It is also significant. So let's put this in decimal form. 7.110 times 10 to the third. So, I got to bounce that ball, make it bigger by a magnitude of 3. Don't let me mess with you. If I don't see that dot at the end, I'm going to mark you 0, and you won't be my hero. So how many sig figs do we have? 4 significant figures. Don't forget that, because it will be on your quiz. Looking at this letter D, I got you now. There's no decimal point at the end. And because there's no decimal point, that means these zeros are not significant. So I don't want to see them. But you still assume the decimal points at the end. Got to keep the magnitude of the number. So we bounce it back 3 times. The original number is larger than 1. So it becomes 5.9 times 10 to the positive 3. How many sig figs do we have? You should be able to look here, in the decimal form or in scientific notation, and tell me we only have 2 significant figures. Now let's look at this last one. Don't let me fool you. Do you see this -2? That means that this number has to be what? Less than 1. So you got to bounce that ball and make sure that the decimal form is less than 1. Bounce it twice because it's 7.890 times 10 to the -2. So when we write this out in decimal form, 0, I like the 0 point in the front. Okay, I'm old. People need to see that. Then we start 0, 7, 8, 9. Look at me. A 0 at the end. Why did I do that again? Because the 0 is behind a sig fig and behind a decimal point simultaneously. It is significant. So how many sig figs do I have? 4. Very good. Now you can do this. This will be on your quiz. I'm looking forward to seeing that wonderful A. I know you can do it. I believe in you.